Hi, you are welcome to another tutorial on redundation and you. For today, we will be looking at Matlab. So we'll be solving a problem that has to do with stress on a body. So the question says, this particular question 3b, the question says the normal and shear stress on a plane at an angle theta to the horizontal as shown in figure 3a are given by this. So this is the normal stress in terms of theta. So equals to sigma y plus sigma x over 2 plus sigma y minus sigma x over 2 cos 2 theta plus tau sine 2 theta. So that is the normal stress on that plane. And this is the tangential stress, that is the shear stress on that plane. So this is the plane, this is the oblique body itself. So this is the angle theta, this is the normal stress, this is the normal stress too. Both are tensile, and we have the shear stress. So we are to determine the normal. The question says we are to determine the normal and shear stress on the plane at a particular angle 30 degrees to the horizontal. So that is the first thing we are to determine. The second says we are to determine the maximum and minimum stresses on the plane. What that means is that we are to determine the maximum and minimum principal stresses on the plane, that is the major stress and the minor stress, and that is when you have your shear stress to be equal to 0. That's when you have your principal stresses. So that's the second part. And then the third part says we should print out the result to the console, that is in the command window. We should print out the result there. So how are we going to go about this? Now for the first one, that shouldn't be a problem because the formula has been provided. Then the second one, we don't have the formula for the principal stresses, so we are to determine that on our own. So we are to determine the formula, though you can just check textbooks to get the formula for the minimum for the principal stresses. So when you have that, then you'll be able to compute this with Matlab. So let's just go ahead and try that out. So now we want to determine the normal and shear stress. We also want to determine the maximum and minimum stresses on the plane. So let's go to Matlab. I'll open my Matlab. My Matlab is open already. So you just open your Matlab just as I'm doing right now. So this is the command window. We are not typing on the command window, we'll be typing on the editor. So come to home, then you come to new. You can go to new script from there. Here you can just pick new script, or you just come here and say new script. Okay, so when you have that, then you see your command window is here, then your editor window is here, so you can see editor. So here you can type your code, then in the command window you will see your your solution, and then you can also work with the command window actually. So the first thing we will do is, just like we did in the previous video when we're working with Visual Basic, we call something a description, to to just put a description of your code, so that whoever is reading it, it will be easy for the person to interpret your code. So right now, but in Visual Basic what we use is this single quotation, but in Matlab what you need is the percentage sign. So use the percentage sign. So right now what we want to do is we want to let me close this so that this will be okay. So what we want to do is we want to determine the normal and shear stresses at 30 degrees. So I'm going to write that. I'll say okay, determination of normal and shear stresses at 30 degrees. I don't have the degree sign, so I'm using I'll just write it as a word. Okay, so when you come to the next line, Matlab usually numbers each line, each row. It will number each row. So whenever you have a problem, it will be very easy for you to say, okay, go to number 14, go to number 12, go to number whatever. So that is that. You can put a space as well, so that your code won't be too clumsy. So now the next thing is we want to determine the formula. Now the question says we should determine the normal and then shear. We should determine the normal stress and the shear stress. So we can do that on like one by one. So the first thing you can say, okay, normal stress. The thing now is that we do not have a value. If you look at this, there is no value actually. So we can't say that okay, the sigma x is 124, sigma y is 700, the sigma xy is this and that. So there's no actual value. So what I am going to do is I am going to create something just like we did in Visual Basic. I'm going to create a scenario whereby there will be a prompt where you can input your value, you know, the input value function. So you will be the one to input your value, then your answer will be processed due to that value. You understand? But it being I have a value here, I will just input my value directly and then I'll work with it. So um what I'm going to do now is I will say okay, display. I'm going to use the display function. So I'll say okay, display. Then in your display you put it in the quotation, then another quotation inside, like a parenthesis and a quotation. So display simply means the title of what you want to have here, like the title. So you can just say you can put the same name. Let's say determination of stresses. Let me just say determination of stresses. That's just the display name, and you close every line with a semicolon. So that's that. Display. Now I need a prompt, like I need something to prompt up and say enter the value of so. You know, that's a prompt, something that they make it enter the value of sigma y, enter the value of sigma x, enter the value of sigma xy. So I need something like that. So that is a prompt. So I'm going to use the prompt function. You say okay, prompt equals, then what you want to prompt, then you put the value. So what I want to prompt is I want it to prompt that okay, input the value of sigma x. So this is what I want you to prompt. So you close with a quotation normally with a semicolon. So this is what I want you to prompt. Input the value of sigma x. So now what will now be the value of sigma x? So you say okay, sigma x itself equals input, then you now call this prompt that is at the front, you are going to call it. So when you want to call, you use parenthesis. So you see parenthesis, then what's the name? Prompt. Just put prompt there. We recognize that. So you close with semicolon, then go to the next line. Also I want to prompt for let me just copy this. You know, I have 3 unknowns there. This is what I'm talking about. You know, I have sigma x, the one on the horizontal, I have the sigma y, and I have the sigma xy. You understand? So I need to put the value of these 3, but the value is not given. So I'm trying to make a prompt that will allow you to input the value of each unknowns. So I've copied this, right? Control C, and let me come to line 7. Let me say Control V. Then let me say Control V again. Then this is still going to be prompt. Then this is input the value of, let me just say sigma y. Then my sigma y will now be the value of that. Then what about this prompt equals to input the value, let me say this one is stress xy. Then what's stress xy itself? Stress xy equals to this. So you can do this first. So now it knows the value. Now we now have to define what we are looking for using this declaration. You know, you've declared sigma y, you've declared all of them. Now the value is not given, but we have provided that okay, the value can be input. You can input the value, but we don't give the value, but that's like an input. So we've defined what sigma x and what sigma y is now. So what we just have to do is we now have to put the formula so that it will know where to put sigma x, where to put sigma y, and then we can now calculate for what we are looking for. So what are we looking for exactly? We are looking for the normal stress at angle 30 degree, the shear stress at angle 30 degree. So let's do that. Say okay, the first one. So let's create a description as we do. Let's say normal stress at 30 degrees. Okay, so the first thing is you want to determine the normal stress, right? So you can say normal, I don't want to put space, normal stress equals, now we are going to input this value, the formula. You know the formula is given already, so what we just need to do is to enter the formula. So we have sigma y plus sigma x over 2. So let's write it. So I'm going to write, okay, sigma y plus sigma x. Now I want to divide by 2. That means I have to put a parenthesis. There's a divide by 2. If there's a parenthesis there, then there should be one here too, right? So definitely there'll be one here too. So you can see there's a blue line that just showed right now, telling us that this and this, they are covered. So divide by what? Divide by 2. Okay, then plus this and plus sigma y minus sigma x over 2. So plus, let me just put space, plus sigma y minus sigma x divide by 2 again. That means there will be a parenthesis. Automatically there will be 1 here. Let me, after the parenthesis, you see something that happened, there will be a blue line. You can see that telling that, okay, this and this are now working together. Now divide by 2, right? Then multiply by cos 2 theta again. So if I want to multiply, and if I want to multiply, that means I have to put a parenthesis here. So you can see this. So I also need one here again to close it up. Okay, automatically it has recognized that. Then multiply by. So multiply by what? Cos. You have to open bracket because you have 2. You know, cos this and this. Well, you know, when you want to multiply two things, you have to put them in the. So 2 times theta. So 2, and what's theta? Theta is 30 degrees. There's no degree here, you work with radians. So when you convert 30 degrees to radian, that will be what? That will be like pi over 6. So that will be like 2 multiplied by pi over 6. So that's cos 2 multiplied by pi, just pi, divided by 6. Then you close the parenthesis. Okay, so is that, or no? Then plus sigma stress xy, right? Plus stress sy sine 2 theta. So plus stress xy multiplied by sine 2 theta, right? Stress xy multiplied by sine, open bracket, 2 multiplied by pi over 6. So close the bracket. Then this and this are now. So you close everything with semicolon. Then move to the next line. So we are done with the normal stress. So we also need to do what? Calculate the shear stress at 30 degree. So let's put the description. So shear stress at 30 degrees. So let me say shear stress equals, so what's the formula for shear stress? Also given. So the shear stress, this is that. So that's still sigma y minus sigma x divided by 2. So that's, is it minus? I think y minus x, yeah. Sigma y minus sigma x. So that's sigma y minus sigma x parenthesis, right? You can see that you have something like trying to tell you that that's not correct. So if you don't have, so automatically you know what to do. Divide by 2, then plus, okay, it's not plus, multiply by sine 2 theta. Multiply by sine 2 theta. So I think I will have something here too, automatically. Multiply by, so there will be 1 here too, because I'm working with multiplied now. So multiply by sine, open bracket, 2 multiply by theta. And what's theta? That's pi over 6. Then you have to close the bracket. Okay, so is that okay? Then I think I have plus, no, it's even minus stress xy cos 2 theta minus stress sy. So this is minus, okay, so minus stress xy multiplied by cos 2 multiplied by what, theta, which is what, pi over 6. Okay, so that's all for that as well. Then you close this with the parenthesis, with the semicolon. Then we are done with question number 1. We are done with what? Question number 1. The question number 2 is now says you should also determine the maximum stress and the minimum stress on this plane. So how do you do that? The calculation is here already. Okay, this is the calculation. So this is the formula for the major, which is the maximum. So maximum, and then this is the formula for the minimum. So let's do the maximum first. So this is the maximum. So let's do what we've been doing. First of all, it is better you create what's it called, a description. So you say, okay, maximum principal stress. You see that's in green color. So you can say, okay, number 1, you can say, let's call it maximum. Let's just call it maximum. So maximum equals to, then you write the formula. What's the formula? The formula is sigma y plus sigma x over 2. Sigma y plus sigma x divided by 2. Divided by 2. So what happens here? You know it. Divided by 2. Okay. Then plus. Then we now have the square roots. Okay. So we have a square root. So that's sqrt. So what will be inside that square root? Parenthesis. Good. Then sigma y minus sigma x over 2 squared. So that's like this. Sigma y minus sigma x. Then what, divided by. You know that divided by has to have another parenthesis for that. Gongo. Divided by 2. Don't forget, this parenthesis is, this first parenthesis is that I want to have something in a square root, but this one is because of the division that I want to do here. Okay, so that's why you're having 2 parentheses over there. Then which other one? Then plus stress square. That's stress sy. So that's plus stress xy square. So you have another parenthesis. So that is all for that. Then close your. So you close that. So the next thing is to do what? So the next question says the minor stress. Minor stress, which is the minimum. So the minimum, this is the formula as well. So you can say that, okay, I have a description which is good. So you say your minimum principal stress. So let's give that minimum. The name is minimum. So we are looking for minimum equals to what's the formula? The formula is sigma y plus sigma x. I think the only difference with this one and that one is this minus. Let me check. Okay, I think that's the only difference. So that is more interesting. So let me just copy all of this. Control C. Then I'll just paste it here. Control V. Okay, so I think this will now be minus. Okay, so that's all. So we are good to go, but that's still not the end of the question. The question says at the end of the question it says we should print out the result to the console. That is, we should print out the result in the command window. So how are we going to print out the result? What it says is that, okay, the result you have here, you want you to print it out here. Okay, so you want to see the result. So let's say a description, just as usual. Say a description. So say print out the results to console. Okay, so the function for print is f print f. F print f, then you open brackets and close it and tell us what you want to print. Now there are two arguments here. One is the name you want to print it as. Number two is the name of what you want to print. If you look at this now, the name of what I want to print is maximum. If I want to print this one, if I want to print this, the name of it is what? Maximum. You know, maximum equals to this. So the name is maximum. So I can decide to say I want to print it as maximum stress. You understand? You know, I want to print it as maximum stress, but the name is maximum. So I will say I want to print maximum as maximum stress. You understand? So how are you going to write that? One quotation, then the backward stroke, then n, then you now write the name. Okay, what is the name I want to save it as? Let's say I want to save it as maximum stress. All right, and that's is equal to, then the new one, the name it has gone, which is the name it has here. Now you are going to write that as well. So you see your backward slash and comma and n. They are now going to input the name. So what's now the name here? Maximum, right? So you say maximum. All right. So you close your what's it called? You close your function with what? Semicolon. No, that's not the semicolon I want. Okay. So I also want to print. No, I think the first thing I should even print here is what? The first thing I should print here is normal stress, so that I know my answer can just be in a normal arrangement. You know what? The name I have here, let it be the same name I want to print it out. You understand? So let me call this normal stress. Okay, but I don't have a space here, so let me just say normal. The first one is what? Normal stress. I'm just trying to have it in a normal arrangement. So the first one is normal stress. So what I should have here, the real name that it has there is what? Normal stress as well, but no space. I mean for this. Okay, so let me copy this. Control C. How many things do I want to print? I want to print this one, 1. I want to print this one, 2. I want to print this, 3. I want to print this, 4. Okay, so let me paste it 3 more times. Control V, Control V, Control V. Okay, so the second, so I've printed this first one, right? So the second one I want to print is the shear stress. So let this be shear stress. Then this will also be shear stress, but without space. Shear stress. Then the third one is maximum. So let me just print maximum, or let me say maximum principal stress for this one. Let me print it as maximum principal stress so that will be easy. Maximum principal stress. All right. Okay, I have another stress. Let me just clear this. Okay, so this will now be what? Maximum alone. You know the name Gongon is maximum. So you say, oh, I didn't close the parenthesis. Maximum. I didn't close it. Okay, so we are done. So we have another one which is minimum. So let me name that minimum principal stress. So minimum principal stress. So the name will be what? Minimum alone. So the name will just be minimum. Okay, so I think we are done. So what we just have to do is let's run it and see what we have. So let's run. It will ask us to save it. Let me save it as stress problem. But you won't put what's it called? You won't put space. It doesn't like you to. So you just save. Would you like? You don't have permission to save in this location. Would you like to save in the user folder instead? Okay, it is saving in local disk. So let me save in desktop. You understand? Let me save in desktop. So then you save. So, I can't save. You can't save in your local disk. Local disk is not where you can save. So it asks you to change folder. Okay, good. Run your program. It says input the value of sigma x. That is the normal thing. So the first thing you are seeing here is what? Stress problem. Stress problem. This is what I used to save the editor. That we just saved now, that I told us that we can't save in the C drive. So this is the name we used to save it. So that's the first thing it's going to bring, the title of the editor. Then the next thing is what? The display. What I told you to display as a title, like the normal title. From the beginning I told you that, okay, display so, which is this display so DISP, display this. So, and that is what it is doing right now. Determination of stresses. And what I have in that display is what? Determination of stresses. I told you to display this like the title, just like the title. Okay, so when you come here, say that, whoever sees this and say, okay, determination of stresses, okay, that's what we want to do. Okay, so the next thing I told you to do is what? I said it should prompt something. And what is that thing you should prompt? Input the value of sigma x. And that is what it has prompted here. Input the value of sigma x. Then what is the next thing? Sigma x input prompt. That is, I am to input that prompt. So let me input it here. So let me say my sigma x is what? Let me say 2400. Then next, it will tell me that, okay, input the value of sigma y. Let me say 2400 again. Then it will tell me to input the value of my stress xy. Let me say that one is less than that. Let me say this one is 1.8. Okay, then I am now expecting it to print my answer. So it says, okay, that's brought my answer. Stress xy, shear stress is equal to minus 900, but it's bringing a lone trailing black backslash is not a valid control character. I think the only place I have that is well, that's what I use for printing normally, but well, that's not a problem. We have the answer. So my normal stress is equal to 3. We are printing 4 things, right? The first one is normal stress. So my normal stress is 3958.85. All right, you can see that what you have at the left here, which is /n, the name you want to give it, you can see that's what I'm having now. Normal space stress. So that is what you're having here. So normal stress. Then the second one should be shear stress, right? So your shear stress is also what? Minus 900. Okay, so the next one is the maximum principal stress. Maximum principal stress, which is 4200. Then the minimum stress is 600. So that will be the end of this particular question. Thanks for watching to the end, and don't forget to subscribe to my YouTube channel. Thank you.